Graphing a parabola of the form y equals ax squared plus bx plus c. Our approach to graph this parabola is actually change its form. In other words, change the equation. Let's change the equation to be this. Y equals a times x minus h quantity squared at k. Where hk is what? Where the coordinate hk is the vertex. So why don't we do that? We're going to use a process called completing the square. So y equals, and then let's factor out the 5 halves, and let's see what's left. We have x squared, and then x, what do we need to multiply to get negative 20x? So let's try 8 minus 8x. Yeah, that would do it. And then we'll leave a space there to complete the square, and then add 33. So we left two spaces here. We left a space here, and we're going to leave a space here to complete the square. So divide this middle term by 2, which is 4. 8 divided by 2 is 4. Then square it, which gets you 16. So we're going to add 16. Now, be careful. You didn't really add 16. Okay, you really added quite a bit. I'm actually going to now take off or subtract 5 halves times 16. Okay, that way it looks like we've only added 0. So notice we actually added this amount right here. So we need to subtract it off to make sure that it's equivalent to the expression above. Okay, equivalent to this expression here, marked triple star. All right, what's so special about completing the square? Well, it gives you another perfect square. And that perfect square is going to be x minus 4 quantity squared. Now here, what do we have? We have 33 minus 40. 33 minus 40 is negative 7. And so we have a vertex. Our vertex, remember, is hk, which is equal to 4 and negative 7. Now this parabola is pointing up because the coefficient is positive 5 halves. So why don't we create some graph paper? You might have your own graph paper. That would help. If you have a straight edge, that's always handy, just to get some nice axes here. A 4 comma negative 7 is actually in the fourth quadrant. So I might need a little bit more space in the fourth and first quadrant. So draw some axes there. I decided to use a straight edge. So let's go 4 units to the right. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Negative 7, 4. And then we have a parabola with a vertex right there. Why don't I draw this in red? There's the vertex, 4, negative 7. And now we just need to pick some ordered pairs. We do have the axis of symmetry. I'm going to pick on the y-intercept. So the y-intercept occurs when x is 0. The y-intercept occurs when x is 0. So let me draw a line there. So we're going to try to find the y-intercept when x is 0. And what is that? Y is now equal to 16 divided by 2 is 8. 8 times 5 is 40. And 40 minus 7 is 33. So we do have a y-intercept of 0 and 33. That might be a little bit off our scale, but that is simply another ordered pair. So maybe we'll try a different approach. Why don't we make a t-chart of x's and y's? And we already have one ordered pair. That ordered pair is 4 and negative 7. So let's do, let's try x to be 2 and then x to be 3 and see what we get. So if x is 2, we get 3. And if x is 3, we get 5 halves minus 7 halves. So what's 5 halves minus 7 halves? I'm sorry, we get 5 halves minus 7. When x is 3, we get 5 halves minus 7. So 5 halves minus 14 halves, which is negative 9 halves. We get negative 9 halves. And when x is, well, yeah, the next one would be what? Let's try x to be 5. And actually, I don't need to try that much harder because we have something called the axis of symmetry. So when x is 2, we go 1, 1, 2, 3, and we plot a point right there. So if you go over 2 units to the right of 4, 1, 2, that's 6, and then go up again, we know there's got to be another ordered pair right there. Why don't we put that label in our t-chart? 6 and then 3. Now, I forgot to plot the coordinate 3, negative 9 halves. So when x is 3, we need to go negative 4 and 1 half. When x is 3, we go negative 4 and 1 half, right about here. And when x is 5, we also go what? Negative 4, negative 4 and 1 half. And there we go. We actually have a very, very nice symmetric parabola that is pointing up. Okay. And the vertex is 4, negative 7. In this case, this parabola is focusing on a minimum y value, and that minimum y value is negative 7. Why don't we circle our work that's necessary for our graph? So the work that's necessary is here, and you definitely want to show your ordered pairs, show a labeling of ordered pairs. So this is another appropriate evidence. Okay, and then finally, let's circle our answer, which is actually the graph of the parabola right here. So 3 phases of work here, right? Completing the square to get into the graphing form that allows us to see the vertex, and then getting enough ordered pairs and using the axis of symmetry to draw our final graph. Make sure you put arrows at the end of your graphs. As usual, draw your graphs first. Draw your graphs with arrows at the end.